se esistono, vengono soffiate via. Qui c'è un'energia unica che cambia il mondo, genera intesi, supera i limiti. Qui sono nate aziende che hanno colto idee e opportunità. Qui le menti brillano, pensano più forti, creano con una visione chiara. Qui, dove l'innovazione è al servizio dell'umanità, il futuro avrà una casa. Qui, dove inizia il futuro.
Buongiorno, sono qui per presentarvi la nuova edizione di Trieste Next. Il titolo della 14ª edizione di Trieste Next è La vita dentro, dialoghi tra scienze e tecnologie. 3 giorni per riflettere su come la scienza e la tecnologia ridefiniscono la vita, su come le discipline STEM dialogano con le scienze umane e su quali nuove domande emergono per il nostro futuro. Medicina di precisione, intelligenza artificiale, sostenibilità ambientale, robotica, biotecnologie e tecnologie quantistiche sono solo alcuni dei temi al centro di Trieste Next. È questo il fil rouge del festival, con un programma di oltre 100 eventi in inglese e italiano e oltre 300 relatori di fama internazionale. E ancora, il premio Trieste Next Science Book of the Year, le 70 attività per le scuole e i 40 spazi espositivi e laboratori aperti a tutti in Piazza Unità. Prima di accogliere gli ospiti del prossimo evento, a nome dei promotori e copromotori della manifestazione, vorrei ringraziare tutte le istituzioni scientifiche di Trieste, città della conoscenza, e le istituzioni che hanno collaborato con noi. Il main partner del festival, i partner e i content partner della manifestazione per il contributo fondamentale. Grazie anche ai media partner e ai partner tecnici. Infine, un grazie speciale ai 200 volontari di questa edizione. Ricordatevi anche di controllare il programma aggiornato degli eventi su www.triestenext.it, al quale potete accedere anche da questo codice QR. Buon ascolto e buon festival!
Okay, thank you. Hello, everybody. My name is Stefano Seriani. I am a professor here at the University of Trieste. I teach robotics, and I will be the host today for this presentation. This is this conference, Shaping the Future of Space Robotics. These are our guests. Let's go here. Okay. So meet Marilena Amoroso. She is the head of human and robotics exploration sector for the Italian Space Agency. Over there at the end, you can see Gianfranco Visentin. He's the head of automation and the robotics section at the European Space Agency. And Armin Wedler, he's the head planetary exploration team at the German Space Agency. Okay, so. Okay, so today I will tell you about the topic of space exploration. I will host this conference. We will discuss between me and our guests about the topic. And to start, I will play a video, which is an introduction. Okay, it's 3 minutes long. It's music, but there's no music, so you will have to imagine it in your head. Okay, so this concludes it. The music now fades out. Okay, so yeah, sorry about that. So the first topic we saw is planetary exploration, right, in the video. So planetary exploration, in this sense, is the exploration of other worlds by the use of robots, okay? So to start our discussion, I would like to ask our guests, why do we use robots to do this exploration? What can they do that we can't or shouldn't do? Who should take the... You can, yes.
I need to. Hello, everyone. Good evening. Thank you for the invitation to this event. Take the opportunity to talk about robotic exploration, the new era of the robotic exploration. Of course, the robotic is very essential and fundamental. It's play important role on the planetary exploration because we need to study, characterize several planets in our solar system. And it's important to achieve the planet in very far from Earth in harsh environmental condition. Is the radiation? If we think the radiation, environmental, and we need to the high temperature, the very condition is not fair or safe for the human, so that the robotic play a role of our eyes, hand, hair in the deep space. In the past years, we had a lot of several exploration mission to Mars, Jupiter, Saturn, in order to analyze, to collect data and information about geophysical characterization, to understand how the atmosphere of the solar system planet works. And we get a lot of information, but in these lately years, the robotic exploration paradigms change. Now, the International Space Agency, the science entities or commercial entities are working in order to realize new technology, new challenge in order to pursue the Moon to Mars strategy. Then the Moon to Mars strategy, the principal objective is to take the first human on the Moon, after that to Mars, and beyond in the next future. But anyway, the Moon, it will be represent a test bed, the first test for technologies, the new competence to acquire, to manage how the human could be achieve the Moon surface in a safety way, and how the human could be in Moon surface or Mars surface in a permanent state. So that we need robotic in order to utilize resource, in order to have a habitation module, in order to build the infrastructure, so that we the objective is to have a small, let me say, village in which the human could be move and act for experiment.
Okay, thank you. So essentially what you're saying is that we're transitioning between a phase of exploration and to prepare to human presence, essentially. Okay, so how do you see, Armin, how do you see mobility evolving in robots to achieve this goal?
Okay, switch on. Thank you, first of all, for having me here, and very proud to be invited. And yes, I think we are currently all working on Europe, worldwide, on enhancing robotic capabilities to, let's say, have more potential use cases in exploration. As Marilena already mentioned, there are a lot of missions planned on a European level, on an international level, also in cooperation with US and worldwide, let's say. So the use in general is enhancing, and that many research institutes as ours, as you, as the University in Trieste, but also in many other places, are enhancing mobility and robots. And let's say, to also frame a little bit to what's your first questions, why we should use robots, and of course exploration, and the long view, we want to have astronauts on a planetary surface. I think that's the big vision. But first of all, we want to not, let's say, expose humans, astronauts, to danger. So the use for robots is argued with, let's say, keeping the humans out of this danger zone. And second is, of course, costs. So to bring a human into an, let's say, really space flight or bring it on a planetary surface, I'm not really sure, maybe Gianfranco knows more, but I think I would assume something 100 times cost of such a mission, having a human astronaut, let's say, putting the feet on the lunar surface, for example, rather than putting a rover. And as Marilena already explained very well, I mean, there are very hazardous planets out there. So, and we also we have a lack of knowledge. So it makes absolutely sense to, let's say, enhance robots to explore first, give us knowledge, take some data, give us really, let's say, close knowledge gaps. But of course, also as a big vision to have a permanent base on a lunar surface, for example, where I think the whole world is currently working on permanent station of humans' presence on the lunar surface. Robots will probably be the first who establish such a base, who do precursor missions, who explore areas which are the most suitable for such a place, and then later, of course, maintain and support the astronauts' activity, because the most costs are actually the astronaut hours. So if you have an astronaut on the surface, you want to, let's say, keep him doing only interesting and important things. I think we are all enhancing mobility in many different aspects. I think maybe we can talk later on specific mobility.
Thank you, Armin. So I have a last question for Gianfranco. In your long career, what are the lessons you got from robotics that could help in this transition to human presence?
I think we need to go back to the previous question, because one important thing to understand is that robotics on planets is a very ethical thing. We don't fire anybody through robots. It's one of the few uses of robotics that actually help humanity. And why do we need robots? Very simple. They need just a one-way ticket. You don't have to pay for the return. This is very important. And also, that ticket is not for the Maldives. The place where we go are horrible. They're absolutely horrible. You see, when astronauts in the 60s went to the moon, they just landed in the best period of the lunar day. The lunar day is 28 days, terrestrial days. And the temperature swings between minus 120 to plus 120. And they only stayed few Earth days, because otherwise would either cook or freeze. This is the problem. So that's the reason why we want to bring first robots to create an environment that is suitable for humans to come back. It's very important. Then the mobility will be very important. I mean, if the moon is a small planet, but I think it's as big as in terms of area as Asia. So it's a big place to go around. You need mobility. And if you take Mars surface is equal to all the surface of Earth, not the one underwater, of course. So you need mobility, because where you land is not necessarily where you find the things which are useful. Then, what is the lesson that robotics in space can bring? I think ethically, for me, it's very nice to think that robotics can help and not be a vehicle for more income, for increased profit, and so on, can actually do very important dirty job that spare human life or diminish the risk to human life.
Okay, thank you. This was insightful in a way, in many ways. Okay, so one thing that I don't think we touched as a topic is essentially the collaboration between robots. Okay, so as of now, we have, let's say, as far as I know, the missions in general are single robots. Okay, so what do you see? What do you think about having more robots, so fleets of robots to collaborate to achieve this goal? Is it feasible? Is it within reach? Is it useful?
Yes, you have this is a good question, because we are going to realize a basement on a moon surface, after that Mars surface in the next future. It's important because if you think the human on the surface, on the moon surface, we need to have a telecommunication system. We need to have a technology, robots could be provide a lot of energy. The power is very important. We need to have a habitation module. We need to have a rover, because the human could be moved around the basement, and these robots all together have to link each other, have to talk each other. And for that reason, in Artemis architecture leads by NASA, the principal scope is to put together all elements of the architecture in order to this robot could link each other, could have the same understanding, the same requirements, and the same scope. For example, Italian Space Agency and NASA are collaborating to realize a multi-purpose habitat module. We are in the Artemis context. We repeat we digest the request to Artemis architecture, and one of the scope is the module could be talk with the other elements, the rover or the lunar rover, the navigation pointing timing, with the communication satellites, because another important project is in charge of the Europe, is to realize a network, a satellite network for telecommunication. So that it's very important to have to realize the new technology that based on with a common requirements and in order to link each other.
Okay, so I think we will get back to this topic when we talk about analog missions, I think.
Mm-hmm.
Okay, so regarding this, I would say we start talking about this part right now. So analog missions, okay, so analog missions are useful to practice, right? So they're useful to practice, to test technology systems, robots in this case, before the actual mission. So as I know that you all have some experience in this, so I would like to ask you essentially Armin, I think, at this point. What are the merits of analog missions in your experience, mainly?
Yeah, as you mentioned already, I think with these analog missions, we can test things before, let's say, sending it out to the planetary surface. And we, of course, look for analog missions for very equivalent places where we can perform such missions. And also, let's say, this aspect of cooperation maybe have 2 points, I think. One is a technical point. You have, if you go from construction site, for example, building such a village, if you look at the construction site, you have different experts. You have an electrical guy, you have a mechanical guy, you have caterpillars, you have drilling machines. So you need to combine this aspect. Second is political. And this political, I would like to enhance a little bit on the motivation also for the analog missions, because not only different nations need to work together, need to understand together, but also different, let's say, backgrounds. You have technical engineers, which come together with planetary scientists, which come with mission operation teams, and which come with different viewpoints on science, will work in such a mission together. And I think politically, these multi-robot systems are later these cooperation aspects, but on analog sides, I think we have also this cooperation of these different knowledge groups, and they need to learn how to work together. They need to learn how the other people speak, and they need to understand it. And I think that's one aspect, a part of, let's say, qualifying your technology towards a certain level of readiness, which is, of course, a goal. But this, I would say, this human aspect is much more relevant in analog mission, because you all try your mission in which a very cost-intensive mission on a later stage. So if you really send out this robot to lunar surface or whatever, you will have one chance. As Gianfranco said, you send it, and there's no way to repair something. There's no way to change something. So that's this one goal. So, and this should really be precise. That's why analog missions are key. And I'm also very happy in the first video we show.
Yeah.
You show the analog mission I was highly involved in on Mount Etna. So nice Italian volcano, which is perfect for certain.
More than once.
More than one.
There were more than one,
yeah.
let's say, demo missions. Yeah.
No, I like analog missions. I really spend a lot of my work time in that, and I really believe also that, I mean, it's for every engineering piece, I think, a part of having a solid foundation in all engineering aspects, you need to test it. You need to go out and test your developments and bring that in real application. And that's what we're doing in analog missions.
Thank you, Armin. And Gianfranco, do you agree?
Yes. Why do we go for analog missions? Because nature is a lot more complex than we can understand. So we test in the lab, we make things that work in our lab, move around and so on. But our lab is a reconstruction of what we understand of the environment. It's not the environment. So what you like to do is to bring your stuff into a place that has been shaped by the same forces that shape the environment on Moon, on Mars, or whatever we're going. And then you run your system, and you always, we've been to the Atacama, to many, many deserts, to Morocco, to the all sorts of places. Every time we test something, the rover gets stuck. And then it's always, why didn't we think of that? It's something always so stupid, but it's the complexity of the environment, the interactions of the soil with stones, and that makes things that can be grossly underestimated if you don't test it in an analog environment. And you don't want to do those discoveries when you're on the moon. That's the problem. You really want to do them long before, because those mistakes are very expensive.
Thank you, Gianfranco. And at this point, I would like to ask you if you agree, and what is your experience in this? Have you ever took part of an analog mission or worked in that direction?
Yes, in Italian Space Agency is to support the one of the the activity in robotic exploration is to sustain analog facility. We have in Turin the Moon and Mars analog planetary in order to have a facility to put in place the first test for the first technology, such as rover or technology dedicated to the mobility. This is a new development, and we need to taste this new technology in ground facilities that it could be represent the environmental Moon or Mars. And of course, for the other new technology, new development about to extract oxygen by a regolith moon, is important to test the breadboard in first in analog situation, analog environmental. And of course, the same for the module, the habitation module. First, the different environmental tests will be in place in analog facilities.
Thank you very much. Okay, so you mentioned regolith, so I will take again the chance to go to the next topic, which is the in situ resources utilization. This is ISRU. This is a hot topic, okay, and essentially it is the utilization of resources that you can find on the spot. So, for example, on the surface of the moon, to let's say extract things that you need, or substances that you need. So regolith is the moon dust, right? So why is this a hot topic, and how? What does it? Let's say, what does it? What is its connection to robotics, Gianfranco?
Right, regolith is not the only resources. So regolith is, by the way, if you don't know the term, the regolith is just the dirt on the planet. So that's the way it is called. It's not called soil because normally soil contains biological element. Instead, we believe that the regolith is completely sterile. What do you do with it? First of all, it's a bulk material, and it contains minerals. Now, if you want to create infrastructure for people or factories to produce fuel to go around into other planets and so on, it's a basic material that could be used. We are investigating processes to essentially extract those basic materials. So you can extract oxygen, you can extract hydrogen, and then you can make, essentially burn them in rockets to go away. These are expensive processes, and also the quantities of these elements that you get into regoliths are not very big. So you need to collect mounds of the stuff. And you also need to have fairly high energetic processes. But here is the good thing. So the moon, first the target for in situ resource utilization is close to Earth, so it has the same solar constant of the Earth. Do you know, guys, what is the solar constant? Yes? Yes, but the thing that is relevant for the ISRO is that fact that you have the same amount of sun that is getting on the moon. Actually, it's even better because, okay, the solar constant on Earth is about 1400 watts per square meter. But this is what it gets on top of the surface. Until it gets down to ground, we get something 800 watts per square meter. On the moon, you get all those 1400 watts per square meter. So you can use that energy to make very energetic processes. And so you can derive metals, you can derive oxygen, hydrogen. You can even take silicon. There is plenty of silicon over there and make chips. And there are also scarce materials that volatile and other volatiles, but also other metals. It's plenty of titanium there. So you can really use robots to collect a lot of this stuff, bring it to the processes plant, and also help in the production process. In the end, every production process is made of stages. You take the bulk, you sift it, you put it into another place. So the transportation of the intermediate products from one place to another is going to be taken by the robot. And the robot eventually could also make use of the materials. You can conceive a system that actually can build other robots. This is far in the future. But the first target to regulate actually would be the production of the fuel and the oxidant that we will need to go back into orbit from the moon. Because again, let's not forget the return ticket is always the expensive thing. Whenever you go to planets, at this moment, you have to bring the fuel to go down. So you have to fight the enormous speed that you get in going down, not to crash. So you have to use jets to avoid to crash. But also, if you want to come back, you also have to have the energy to come back. So you need to bring the fuel there to come back. So what if we can actually produce the fuel there? It will actually make missions maybe twice or even more, probably something like 70% more efficient in terms of mass transportation.
If I may add, I think no permanent base ever on, maybe on a lunar surface, we managed to operate something on a longer term, but a real base where humans can go and think will exist without, let's say, enhancing such a technology. On the Martian surface, we know all this crazy American which talks about a city. It is not possible if you're not able to really use the resources over there. That's really, I think, a key enabler. And of course, we are at one robot level in the moment. We're thinking about cooperation, and I think that's already ongoing. And I think when many nations work together, we are there. And that's the next steps then.
But talking about in situ, it's not only the regulator that the thing that it's more interesting at the close time. I mean, let's go back into the problem of staying on Mars. The problem of staying on the moon is twice a problem because there is the temperature factor, so cooking or freezing, and the radiation. Yes, because radiations are lethal. You maybe know or don't know, but we are extraordinarily lucky in having a magnetic field around Earth. The magnetic field creates a sort of cocoon that avoids the solar radiation that is impinging into the Earth with all nasty radiation, those heavy protons, heavy ions that are coming that would kill us instantly if there is a solar flare. We're protected by this beautiful magnetic field. But those places are horrible because also they don't have a magnetic field. So they are unprotected against the radiations, and you get them all from the sun and from the galactic space. So one thing that you need to do is to build shelter for astronauts. Otherwise, they cannot stay for two reasons, either the thermal one or the radiation. So they'll need to go back to, I would say, history of humanity, when they were going down in caves or underground. Because it turns out that if you are underground on the lunar surface, the temperature remains pretty constant. There are no such swings of temperature because the regolith itself is a fairly good thermal insulator. So if you go, let's say, a couple of meters under the surface, really there's almost no variation at all. And it's very good because you can design habitats for fixed temperature. As you well know here, for example, you suffer when the temperature is either too hot or too cold because you adapt. So if you have a stable temperature, this is ideal technically. So robots can help this. The very first thing actually will be the possibility to build habitats. And maybe we don't even do those into regoliths, because I think I always say that to go back to the moon, we have to go back to the Stone Age. Because while using the regoliths, there is dust, and maybe you need to 3D print it or all sorts of things that when there are rocks, you take the rocks, you come up, you do beautiful constructions. You can develop again structures, and in Italy we have structures which are few thousands years old, which are completely done in dry stone, no mortar, nothing more, and they're still standing there, and they provide shelter. So we can do those things on the moon by robots. We have done, for example, this. I've had a PhD student that developed a system. We developed a wall of completely built by a robot. The robot was going around selecting stones, looking at them, putting them aside, then running a program which would do an optimization to bring together all these things into a wall. And then we built the wall. But it was not a small thing, because every single boulder was 2 tons, and the wall was 30 meters long and 10 meters high. So it was really a good test.
Thank you, Gianfranco. Thank you, Armin, and thank you, Marilena. So let's say we have, I think, a bit of time for one last question for this, maybe short. What are key technologies? Maybe I think, Gianfranco, you already answered to this, but what are key technologies that you have developed in the robotics field, mostly, but not only, that would help the journey, let's say, to ISRO, essentially, to the in situ resources utilization?
Which is the most elements that could be helpful. I think, as Gianfranco said before, the principal topic about in situ resource utilization, or to this is our topic because we are just in the beginning to realize the new robotics, the new technology that could be put in place, the process to start to collect the sample on Moon, Mars, and to put in place the process to realize, to extract the principal element. I think we have 2 scopes. One is to have in place on the surface to collect and realize the flow, because we need to back to Earth. And the second one, if to help the human survey on the Moon, on the Mars. So that's I think the principal element could be methods or extract methods or water. But we are, as I told before, we are just in the beginning. Now it's very important to realize mission designed to recognize where the resources are located, and where the robotic could be accessed easily to this resource. Oh, sorry. So it's important to put in place a project and process that could be could be allocated the resource where and how can be extracted them. Of course, we could put in place the importance to have a resource in situ, because otherwise we could send the proper land, the flow, and the other resource that human could be needed to transport Earth to Moon or to Mars, this resource, and this has a very huge cost. For that reason, the in-situ resource is the new frontier and the new piece of the puzzle to take the human on Moon or Mars surface.
Thank you. Armin, what is as I asked Marilena, what is a key technology that you have helped to develop that could help the topic of in-situ resources utilization?
Yeah, I will focus now really on my team and let's say also our institute, because DLR is large and we do a lot of things in many different aspects. But I think our institute and we are working on enhancing robotic capabilities. So talking about mobility elements, as it was shown in the first introduction video, we have currently built a real rover with CNES together and JAXA, which goes to the Martian moon Phobos. So we really want to prove that our system is working. Our technology is actuation system, a OBC, so let's say the main computer perception system. It needs to have a certain amount of autonomy. This rover, for example, we have, it's a bit of crazy, but somehow we have every 24 hours, a few minutes where we communicate to the system, and we have a round trip time. So sending signals to Mars, getting that back, something 20 minutes. So we enhance autonomy. Without autonomy, the system would not do anything. So we send a little command and get the data from the day yesterday. So we enhance the capability of motion, of moving. So SLAM, let's say in technical words, where we are mapping the environment, localizing ourselves. And second, I think what is robotic capability key is manipulation. Any kind of manipulation, also talking about this cooperation aspect. If robots want to cooperate, one simple task, I hand you over this cup. In robotics, it's very difficult. You need to consider all failures and things like that. So that's what we are currently working on, capabilities for manipulation and navigation in autonomy.
Okay, thank you. Well, Gianfranco, if you want to add something, let's say technology that you have personally or your team has developed that could help.
It's hard to say because, when the thing happens, maybe what we have developed it would be already old. So, but we have worked on many things. And I think the interesting part that I found more appealing is this idea that in a world where everybody goes somewhere and you can use Google Maps and know where you are and wherever you go, actually we have a problem in space that you very easily get lost. You get lost because there's no GPS and because the conditions that you find at landing are not the one that you expect before getting there. So lost in space is a problem that we have tried to solve, and we have quite some tools. So lost in space is a problem of localization, knowing where you are. And there are two aspects of localization that are interesting. One is knowing where you moved from the first place where you were, which we call local localization. And then the other problem is global localization, which is knowing where you were on a map. We have built quite some interesting solutions for that. And this, I think it's interesting to see. I mean, Trieste is a place a bit of a mountain and at the same time sea. So you can see both localization problems here. And I think a global localization problem can be, there is a very nice explanation that you can have if you're walking on the mountains. You go up on the Carso and you walk in nice woods and so on. And then at a certain point, if you have never been there, you don't know where you are. But you keep walking because you know there's going to be something. There is a landmark, maybe a hut, maybe, I don't know, a construction or a particular peak. And when you see that, you will know where you are. And that is the global localization. Global localization, philosophically, always needs a landmark, some sort of landmark. But of course, the landmark we have on the planet. So you cannot trust that you find a hut. Well, that would be a very nice discovery, but we wouldn't know before that it's there. You need to find different landmarks, and different planets have different landmarks. So we have developed a series of abilities to work in different terrains. I think this is interesting because it's something that you don't do normally on ground. For the rest, many things that are needed for space are actually used in terrestrial robotics, in exploration of the deep sea or places where normally you cannot go with humans. And of course, they need to be refined for the specific space problem.
I just add, because it's very important what he said. I mean, what you need to understand, or what is our, let's say, challenge, is we have nothing on that planet, even no communication, no charging stations. So you need to consider all that. Also regarding localization, for example, the rovers you see, the systems which are on this planetary surface, they need to reach a place where the solar panel is well posed to sun to recharge. All that needs to be considered if you have such a mission. We have no idea where we are. We have no really serious map. For example, for Phobos, where we're supposed to land in 1 year, we have a map of a pixel is 5 by 5 meters. So there can be a crater, which we have no idea where our robot will be then later. Okay, sorry. Hope you could hear. So what I want to underline, we are in environments which are very hazard for our technology, but also are totally unexplored, and there is no service of communication, no service of energy, and no service of localization, which we all have, convenience on Earth now. I think we cannot imagine really how that be. I think the Stone Age time is a good relation.
I think there is a paradigm. I like being in the middle of the mountains with your phone discharged. I think it's a similar situation.
If internet is switched off today, I think many people are in trouble, and that's exactly what we have.
Okay, thank you. Thank you very much. So I think that we have discussed a lot, let's say, on space exploration per se, but all of these activities that we perform in space do leave a mark in any case. Okay, so as do commercial endeavors in orbit, for example. So this leads us to the topic of space debris, right? So space debris, what do you think? Is it a risk? I mean, it is a risk, but is it also an opportunity or not? What do you think, Gianfranco, maybe? I see you're nodding, so.
Yeah, of course. Yeah, this is my personal battle within my organization. Yes. I think debris, you can relate it to terrestrial junk. Terrestrial junk is a problem. The junk that you see everywhere, you want to get rid of it. You put it into a dump yard, and then one day you realize actually that in that dump yard, there are lots of things that you may want to use. I just bring you the example, for example, of the production of cars. Cars get old, you dispose of them. In the past, they were just put in stacks and stacks and so on, and they were always rusting there. And then suddenly, when the price of steel started being very high, people realized, hey, this is all good steel. We should reuse it. I think this is very much the similar situation that we have in orbit. We have, you have seen the animations of that cloud. Okay, that cloud is a bit exaggerated because it shows at the same dimension all the different debris. There are small debris, there are bigger debris, and there are very large debris. It's very difficult to do anything with the small debris, but with large debris, you take a big satellite. A big satellite is a marvel of materials. You see, to survive in space, and the conditions I was mentioning to you are very tough, you need to have the best steel, the best titanium. You need to have the most pure copper and the best plastics and glass and silicon and so on. It's just a mount of incredibly good material. And so why not trying to use it? I mean, these days the technology is not there. And at the moment, these large debris are a problem. They are a problem because they can be hit by small debris and they can be fragmented. You see, when you are in orbit, to stay in orbit, you have to travel at a certain speed. You see, being in orbit is a very simple concept. You throw a stone and the stone, of course, goes down. You try to throw it very far and it goes further down. Suppose you throw it so much stronger, when it falls around the Earth. That's how you get in orbit. So you need to have a very high speed so that you get in orbit. Now, this high speed means that the objects in orbit are really going very fast. But the orbit perturbation means that some of these objects change plane. So they're going on this plane and then slowly, they orient itself into another direction. And then suddenly you see objects that are flying on the same orbit at the same speed, maybe with 20,000 kilometers per hour of difference. Now, even a small particle, 3-4 centimeters, at this type of differential speed has enormous energy. So energy, remember, goes with the square of the speed. So you get this thing, hits a big satellite, boom, enormous cloud of other debris. We want to avoid this. So what do we do with this? At the moment, we cannot reuse the satellite, but we should do something like taking these big debris, which cannot be maneuvered. This is the problem, because we know all the dangerous debris, where they are and where they're going. And in fact, if you take an operational satellite, we essentially move the satellite up to 4 or 5 times a year to avoid collisions, because we see in the debris coming, and we have a 500 by 500 meter window where we put around the debris. If the debris is in the same 500 by 500 window of a satellite, we move the satellite to avoid there is an impact. A debris, we cannot do this because it's dead. It's a piece of junk. So we cannot save it unless we make it controllable again. And this is the concept that we are promoting at ESA, is that we take all those pieces of big junk and we put it together on a large control structure. And the control structure, whenever there is something that is coming, can move away, not take the hit. And if you keep on collecting this, one day, when we have the technology, when we work together to make a good technology, we can go there and there is plenty of materials that actually you can reuse to make more stuff. And the interesting part of this is that when you launch a satellite, more than 70% of the mass of the satellite, it's only useful for the 7 minutes of the life of the satellite, which is the launch. Yes, yes. So, because when you launch, you're launching on a rocket. A rocket, it's a retarded bomb. It's a bomb that does not explode completely. It's just creating a sequence of small explosions. And this really creates a lot of mechanical stress into the system. So you need to make structure into satellite to make it sturdy to resist these 7 minutes. But once you are in orbit, you don't need that structure. You can actually put together a satellite in orbit with speed. Well, I mean, not really that, but I mean, really something that is weakly bonding, because there is no mechanical stress. So in principle, if you take the material that you have used for maybe 10 satellites, in which you have launched from ground to orbit, you can reuse the mass to make it maybe 50 satellites, because there is a much better usage of the material. That's why I think debris can be a very interesting asset.
Thank you, Gianfranco. Yes, a little bit, but still. Yes, absolutely. I will
think, can I add something about that? And a sort of question for Gianfranco is a very expertise on the space debris. We are going to colonize Moon, Mars, and we are at the very beginning. We are the first stone. But anyway, in the next future, we will be probably will be have we'll have different several orbits, several probe around in cislunar orbit, in Mars orbit. If I think the telecommunication subsystem, and if we consider the several stakeholder, international stakeholder, commercial, international agency could be own satellites on different orbit and so on. Do you think we could just in the beginning to put in place something to help us to lesson learning about what happened on the Earth for the space debris? It could be became a problem, an issue for the future, for the moon or for the Mars.
So you mean some sort of treaty for the protection of the outer? Well, there is a treaty already for the protection of the space, and we have things that regulate how you are entering a planet which has potential for life. I mean, we have spent 1.5 billion euros to make ExoMars. Well, actually, you have spent as well, because this was coming a lot from Italy. And the major element of the cost was to keep the system sterile, to avoid to actually bring a bacteria there, not to create new colonies of Earth, but not of the right sort. Yeah, no, there are already this treaty, but as you say, maybe something more should be done to essentially cope with the potential for junk and for pollution and other aspects of exploration in which, say, yeah, effectively you could have, you know, the potential for a planet being ripped off by only one country, or maybe completely impaired for the future. Yes, I think the treaties about the Antarctica are interesting for this, because they also are more or less imposing non-commercial use of the resources there. But I'm not aware. I'm not a lawyer, so I don't know. But it could be a base.
Okay, thank you. I think that the time's up. So I think I want to thank the guests, obviously, from our part, but I would like to ask the public if they have questions for our guests.
So thank you so much for your talk. My question is related with you were just talking about, because this talk is about robotics, and you were talking about something that is really related with sustainability. Like we humans have demonstrated here on Earth that we don't know how to treat our resources and to like manage our resources in an efficient way. So how does robotics play a role in making our paper, like our role in a space, sustainable, and not making the same errors that we made on Earth, on outer space, not only regarding space debris, but also are we treating our residues on Mars or on the moon in the same way that we treated them here on Earth? And how do you apply robotics to solve all those potential sustainability problems in outer space?
Yes, your question is very important, because we have a high risk to go to the moon, to Mars, to other planets, and this run for different countries, different entities could be high the risk that the colonization of the planet can be not sustainable. But anyway, for Mars, there is multilateral cooperation. All the stakeholders, the international agency, cooperate together in order to protect Mars. Mars is protected from a multilateral agreement for a cooperation. Maybe it could be important that each state, each country could be meet together and could discuss about how to protect, how the future, the robotic exploration could be sustainable in the future. I think is a very important topic to put in place.
More on a question, or I could add some here.
Yeah, you could add something. Yes.
Oh, it's a very good question. And I think I just want to add that this planetary protection, what Marilena, what you mentioned, and you also touched it slightly, I think it's in place. And at least all nations has agreed to that, that let's say everything we send, we are not, we hope we do not harm the planet. I mean, of course, but we are, I would say the agreement of the big countries now is headed well, and I think I know what we did for planetary protection before the Martian rover Phobos, so certain amounts of material testing and outgassing, and several things needs to be taken as it lands. What we see in the orbit, what was this picture, is now also occurring that many more nations, but also commercial players. I mean, I don't want to talk about the constellations because they're flying lower, so they're going down earlier, but we see much more traffic in geostationary orbits. And I think that's a danger. And what Gianfranco just mentioned with this, let's say, recycling station, let's call it recycling station, where you collect all the space debris, which might be used later, is already a good approach. And honestly saying, we need to work on that, and we need to ensure that we're not messing up our environment as we maybe did it on Earth. So I'm fully with you, and I can fully underline that. And especially also, I mean, what the danger in this orbit thing is, let's say this is a kind of an exponential function. If something crashes there, it might impact the next one and the next one. And this is an amplifying system. So it's really an exponential function we're seeing here. Now we had when was this accident with the Russian satellite where it was almost about to lose the satellite. So it can be going very quickly, a day, that we have no satellite more in place in our geostationary, and that will impact Earth very quickly. So it is something we really need to take care that we keep our orbits clean where we have our satellites, and we need to take care thinking about ideas. And we are currently working on a 2-arm satellite which can fly to another system and maintain it. So that was your key question, right? What we're doing on robotics. So our idea is, for example, to have a service satellite which might go there and use robotic arms to, first of all, maybe repair it. So there are some broken satellites, but there are also very simple things. So satellite has been launched, a clamp of the solar panel, which is supposed to be taken away, has not been taken away. So this whole satellite has never come in operation. So ridiculous situation. So such systems could be serviced, and that technology is not existing yet. I mean, all satellites could be captured with robotic arms, with nets, with whatever techniques. We need to take care of that, and we are researching on that. So I would say no system is yet in place, but there are a lot of ideas. And also there, I really want to mention that we need to work as humans together for that, because it's a worldwide, it's a global challenge.
Agreed. I think there's a question there. Thanks.
I wanted to ask about technology called solar sails. There, for anyone not familiar, a technology that would allow a robot to travel very large distances in space at a very high speed. I wanted to hear the thoughts of our guests about such technology?
We have had a number of experiments on this, and obviously it is clear that it may work. Actually, it does work, but it presents also all sorts of other problems, including that you have debris. So having a very large surface that works as a sail also makes it a very large target for debris. So the technology of making robust sails it's a problem, because you want to have a sail that is immensely thin so that you can deploy it on a very large surface, not having a large mass, but very thin sails tend to rip off very easily. It's a technological problem. Anyway, it is something that helps for going out from Earth into other planets. It's not a system that allows you to maneuver around very much. It's not properly a sail. I mean, if you are doing sailing, you need a blade in order to direct yourself in a direction that is not the one of the wind. In solar sails, you don't have such a blade. You only follow the direction of the solar wind. So it only helps you going away. It does help, though, for other things. Like, for example, you can use the sails for the orbiting. We are actually experimenting of this, because one of the problems of satellites being dead in orbit is that you haven't done anything for them to come down earlier. However, if you deploy a large sail on a satellite, and it can be done with a fairly small device, you increase the drag. You increase the drag that is caused by solar radiation. And especially if you orient it at the right time, you see, when you are going toward the sun, you can decelerate. And then you avoid to accelerate when you are on the other side. So by building up this deceleration, you can actually come down earlier. Remember, you need a higher speed for being in higher orbit. So you can do that. You can also do that when you are starting to hit the atmospheric layers. The atmosphere is not a 0-1 place. So there is a continuous rarefaction of the atmosphere. So even if you go at 200 kilometers of altitude, you still find atoms of nitrogen and oxygen that can cause some drag. So if you increase the drag, you come down earlier.
I think we have time for one more question, if there is any. Come on, don't be shy. Okay, I cannot see it. Okay, perfect.
Thank you very much for sharing with us such a nice view. And my question is, we always hear about the development that is going on NASA, ESA, but do you know how the research about Mars is going in Russia, China, how they are approaching this issue that you mentioned today? So thank you very much.
This is a political question. Yes, I think we have people within the agencies that are taking care and tracking this type of developments. You understand that they're kind of secretive about what they do. Sometimes they pop up with very important things. They publish what their intentions, but sometimes they come to results earlier than everybody believe they would. And this is, however, in the field of exploration. Other things which relate more to space technology in general, and in particular, a subject that is interesting is what goes on in orbit with respect to intersatellite operations. You understand that whatever you have in orbit is an asset of a country. And if there is a country that doesn't like to see that asset, it develops all sorts of ways to disable this possible enemy satellite. So we don't know much about the research that has been done in that field. By the way, also by the allies, it's not only Russia and China. Those military developments are not very well known, and they're probably very advanced.
Okay, thank you. Again, thanks to our guests. Very appreciated. That's it. Thanks. Bye.
Thank you.